So we got a bit of free time lately, and we're making a little bit of progress with our power drawbar. We got some of the bits and pieces made here. So we got a package in the mail yesterday from Stan's in Koski, and timing couldn't be much better, Stan, because we're getting back at this project now, and I know you were going to send some tubing, and just open her up and see what's on the go here. Stan sent us well enough tubing to run it to next door anyway. And let's just get it all out and then we'll go through it after. Oh, cool. Starrett charts that apparently they won't send to Canada, because I tried their website. That'll come in handy. I will save that one. MasterCard bags. You guys must buy these down at Walmart, yeah? Everybody seems to have a bunch of them. So these are a handful of fittings that we're going to need to connect the air motor and our air cylinder together to finish this drawbar project. And these are the special regulating valves that Stan had showed in one of his videos earlier. And an assortment of fittings to connect to the air motor and to our switching valve. Cool stuff, Stan. It's going to come in really handy. We'll put those in the pile with our drawbar pieces. And a bag with my name on it. That sounds good. I have a funny feeling I know what these are. Now we're going to need something sharp. So these would be the new and improved the stangles, I think Tom calls them. These are a new improved version with the thicker web and the Bar Z logo in them. And they look pretty cool. Did they stick together this time? Yeah, they'll come in handy for sure. We're going to add those right in the box. Great for a little setup work, and just checking to see if things are square. Thank you very much, Stan. I appreciate the gift. If you don't subscribe to Stan, check him out over on his channel. It's Shaden HKW. I'll put a link in the screen there, and you can go and give his channel a view. And he does some interesting stuff as well. So now we'll part off a piece, a little over 3/4, so we can face it down to 3/4. I'm not sure if this is what Toolmex had in mind when they designed this parting tool. We're running pretty much right on the ragged edge of this thing. It's not terrible considering the depth. It's a bit rough, but considering the depth we just cut with it, and it's hanging on a ragged edge on this end, it's not too bad at all. So this is what happens when parting goes bad. We're trying to make a dish, I guess. I lost the insert on the parting tool, and I mean literally lost it. It fell out in the tray somewhere, and I didn't realize it, and this is what happens. Lucky enough, we had enough material to salvage our plate out of it. So the existing center hole in our mill top plate is 1.2 inches. So we're just going to do a center drill and bore this out to the exact same size. This will give us our center point when we do our hole pattern. That's our 1.2. That'll be the basis for our hole pattern to match the existing bearing cover. So this is my plan for the power drawbar. I want to try to keep it as compact as possible, so I'm going to have the cylinder pull from underneath as opposed to push from on top. The blue markings are the hole pattern to match the existing bearing plate on the mill. The red dots are going to indicate where I'm going to put a couple of 3/4 inch uprights for the whole unit to slide up and down on. Haven't got the material for the top yet. I'm going to put a bit of thought into it and see what material I have and come up with a design for the top. So this is a piece of 1" 1045 we're going to use for the posts for our power drawbar. I'm just going to face and center drill each end of it. I left a piece of full 16 inches long so we can split it in half and make our posts. That's why I like cam lock. I'm putting on these, I like to tighten the first cam just enough to take up the slack, make it progressively tighter as you go around. Then you do a second trip around and it seems to tighten the truck on a lot more even. Okay, good to go. So don't be expecting me to best at them now in 4 draw setup times, huh? This actually goes high twice per revolution, so it's definitely not round. But for the most part, it's within 1,000. Okay, it's fresh new carbide. Get her locked down. We got an idiot put on our shaft in here for end of cut. So we'll scratch that one in a little deeper. And come back here and try to get this down to 3/4. Set 0 there, and we'll do a quick measurement to see where we are on this. 915, we need 750. .810, so we'll do one more cut at this feed rate, then we'll slow it down to get a final finish. So that should have taken us to about 760. 63, 62. So we get a mic now and try to get this to really close. $765. 15 according to the mic, so we're dial in 14. See what happens along here. $753, slightly fat near the chuck. I'll try one more cut, a little faster speed for some better surface finish, and we'll polish the rest down to size. $751, maybe a little file and emery time. extra time to get this pretty much dead on because it affects how smooth the drawbar is going to operate. So right here we're just a couple of tenths over. That's a tenth or two. I can live with that, I think. So a bit of 180 silicon carbide. Just going to find a bucket on this. How are you making out? Okay, that's side A done. So we'll flip it over and we'll do side B exactly the same. So those will be our two upright rods for the power drawbar unit. We'll trim them to length after. We're not even sure what length is going to be yet for a while, so we left them about an inch long. Okay, so there's a rough approximation of what it's going to be. We got our rods turned a little oversized. None of the holes are done in the plate yet. We're going to sit down and draw all our layout out in CAD for sure. We got some springs salvaged from some New Year's poppers, actually, believe it or not. Just happen to fit on there quite nice, and I think the length is going to be just perfect on them. So I don't know about you, but I'm ready to drill some holes in the base plate of this power drawbar and try to get this thing finished and operational. So the screws in the top are 6mm actually, so we whip out our handy dandy metric equivalent chart from Starrett, and we find out that our 6mm are equivalent to a 236. So we pick out our letter B drill bit to pop our holes in. We're already centered up on our spindle, so we'll move out the appropriate radius, in this case 2.264, and we'll put in our 120-degree hole pattern. Right. 2.2. 2.264. So we'll lock her down there and start drilling some holes as soon as I get some glasses on. It wasn't too bad for a guess. Okay. So 30 turns on our table. Okay, next step now is to do a counter bore for our metric screws. So we're going to use a 7/16 end mill, sink them down about 1/4 inch. What I'm going to do is install my quill lock on here and bring it down tight. Bring the knee up till we touch off, and then we can raise and lower our quill and get them all the same. Zero. 240. Now we can use our quill and do each one. Get one of our cap screws, make sure it fits. I had to rob one directly out of the machine because I don't have any spares on hand at the moment. It should work out just fine. So that's the first part. Now we haven't determined yet where we're going to put our posts on there, but when we do, we're just going to leave it on the table for now until we determine where we're going to put those pieces and come back and drill more holes. So I noticed a bit of movement in the part where it's clamped in such a small chuck when I was doing the holes. So before I do the next set of holes, I'm going to get a set of machinist jacks and put them in on at 120-degree increments here to give it a little outboard support. So we're just going to put these in there and tension each one till the dial indicator just starts to move a half thou or so, and get them all even. So that should work for some outboard support when we drill our next set of holes. So this is the kind of setup I wanted to go with and try to keep the unit compact. So just laying this stuff on here and doing some eyeball measurements, it looks like we're going to run probably 3,750 between our posts, and we're going to center our cylinder between the two. And so we'll draw it all up in CAD and see if we do have room, in fact, to fit everything in here. Okay, so I get all this drawn up now in the rough measurements that we had measured with scale, and we get a little bit of interference here between our impact motor and our actuator cylinder in the order of 69 thousandths. So I think what we're going to do here is we're going to take all this stuff and we'll move it down. So move this down polar at 0.075. Let's not 0.75, 0.075. And see what that gives us. We still get a little bit here. We can zoom in and check, but it's pretty tight. Okay. So we'll select all our parts again. And we'll do the same thing. We'll bring it down polar another what? Let's bring it down another 0.20. Hardly enough. Another 40. So now we have some clearance between here. See if we can get a rough dimension on what it is. So we have roughly 66 clearance between our parts. That should be lots, if all the measurements are right anyway. So this will be the layout for our for the holes for the actuator cylinder and for the 3/4 inch rods. So we'll go into our dimensions. And put some dimensions on those. Oh, that ain't right. Stop that. So that'll be the radius on those holes. This will be the radius on the cylinder hole. And now we need some angles. So we have an angle from our 0 of 54 degrees each side for the 3/4 inch rod holes. And we have a radius for our cylinder hole. And that one will be at 0 degrees. Should work, shouldn't it? Let's try it out. Okay, so I've got drawn up in CAD what I think is going to work here, and we get our angles from our CAD program, which is really helpful, and our radius. It's going to be slightly larger radius than the existing bolt circle, just to get everything to fit in a straight line and to give us clearance to the air motor. First hole is going to be 54 degrees. We'll swing on around to the second hole. Actually, sorry, we're going to do our cylinder hole first. Since we're set up at 0 right now, we'll come out the smaller radius, do our cylinder hole, and then we'll come out to our larger radius and go to our first rod hole and then swing around to the second one. First radius, 1.404. So that'll be about there. Let's take off our quill stop. Just going to put a center hole in this one for right now. I'm not going to drill this one with our letter Q for, because I was going to try to incorporate the muffler that Stan sent us, and I think I have a way to do it, but we're going to have to do some different operations with it to get it to work. So now that we have it center marked, we can go back to this location later and finish drilling it. So now we'll move out to our 2.307. Very slightly bigger radius than this one. So now we need our 54 degrees. Should have counted the turns on that, eh? Let's see. So 13.5 turns. That's 13, 1 degree, and 2 degrees. That should be our first hole location. We'll go and find out. And these we're going to drill 5/16 and affix our rods with a cap screw from underneath. We'll have to flip it over later and do a counter bore. Okay, so now we'll motor on around and do our next hole. Okay, so now I've got to figure out where we're going from here. Alright, to change of plans, I had planned 5/16 cap screws for those. I found a couple 3/8 kicking around in the junk box, so that's what she's getting. Okay, modification complete. Now we'll drill and tap the rods to go up top, I guess. So there's our two upright rods, drilled and tapped, ready to go. So here's progress on our power drawbar kit today. We got our base plate drilled, got our uprights mounted, and our air cylinder mounted. Hopefully all these measurements are going to work out, and I'm going to have room to get this bad boy in the center. It looks like it's going to be fine. I guess continuing on now, we'll have to design and build the upper plate for this. Not sure what I have in materials just yet, but in the next few days I'll try to figure something out. I think we have room at the bottom for our valve set to go in. We may have to build a custom fitting for down here and allow our hoses and our adjustments to fit in there just nice. I don't know if you can see that there, but the plan is to put these bad boys down here. Keeps the whole unit compact and should work well once we get it done. Lines from the top, of course, will come through the other fittings that Stan provided. So we'll have our two lines come over top to these two lines, and then probably out the back to our actuating valve, I guess we'll call it. Got a few minutes between jobs again today, so we're going to get a little progress on the power drawbar. Today, essentially, I'm just going to copy Mr. Ray Cornelius' design and make a backing plate for the end of the impact tool, and drill and tap the appropriate holes, and we'll put our pipe thread fittings in from the back side later on. We got our appropriate sketch on the go over here, so we'll center up on this corner and work all our measurements off of this end and the back side.